Bismillah ar-Rahman ar-Rahim. This presentation is to describe the histology of the female genital system. The female genital system is formed of ovary, fallopian tube, uterus, vagina, placenta, mammary gland. But in this presentation, it will describe only the ovary. This picture shows the ovary formed of two parts: superficial part and a deep part. The superficial part is the cortex, the deep part is the medulla. The cortex here, this area, is characterized by the presence of different types of ovarian follicles. It is covered by tunica albuginea, and above the tunica albuginea we have the germinal epithelium. The medulla is characterized by being in the center of the organ, and it is rich in the blood vessels. You can see these small primordial follicles as well as different types of growing follicles. In this slide we have the picture of the ovarian cortex full of ovarian follicles, and the central medulla, here the central medulla, which is rich with blood vessels that are stained red in the section. These are the red stained blood vessels in the inner medulla. In this picture, you can see the layer of the germinal epithelium. It is formed of simple, which means one layer, simple cubical epithelium. But at old age, it changes to simple squamous epithelium. Under the germinal epithelium, immediately you will have this connective tissue called tunica albuginea. Then you can see different types of the ovarian follicles. The most superficial type is the primordial follicles. Primordial follicles, they are the superficial follicles. They are characterized by having a layer of simple squamous epithelium surrounding the primary oocyte, whose size is 25 micrometer in diameter. Remember these sizes. 25 micrometer in diameter. Then we have here a primary follicle. It is characterized by having one layer of follicular cells, so it is called unilaminar. This layer is formed of simple, which means one layer, simple cuboidal epithelium. Surrounding what? Surrounding the primary oocyte. The size of the primary oocyte is 40 micrometer in diameter. It has a vesicular nucleus with prominent nucleolus. Also in this picture we have some follicles which are atretic, fibrosed, degenerated. These are called atretic follicles, and this atresia can take place in any stage of development of the follicles, either primary, primordial, secondary, and so on. Here we have a picture for the primordial follicles. Here we have a simple squamous epithelial layer surrounding the primary oocyte. But here we have some atretic follicles. These are atretic follicles. Here at the mark X, they are atretic follicles, this one and this one. Here we have stromal cells in between the ovarian follicles. So we have here stromal cells. We have here the primordial follicles surrounding the primary oocyte with the vesicular nucleus with prominent nucleolus. We have here atretic follicles. They are degenerating follicles. And we have here some stromal cells that will form later on the theca folliculi. Here we have the unilaminar primary follicle. Here we have just one layer of follicular cells formed of simple cuboidal epithelium. Simple cuboidal, not cubical, cuboidal epithelium. And the oocyte here is 40 micrometer in diameter. It has a central nucleus which is vesicular and with prominent nucleolus. Notice the stromal cells present in between the follicles. They will form the theca folliculi later on in the development. This is the picture for the multilaminar primary follicle. You can notice that the primary oocyte is now much enlarged. It may reach up to 50 micrometer in diameter, with a vesicular nucleus in the cytoplasm and prominent nucleolus. Vesicular nucleus with prominent nucleolus. It is very important to notice that we have here this acidophilic membrane surrounding this primary oocyte, which is the zona pellucida. Number 3, we have the stratified cuboidal epithelium called granulosa cells. Number 4, we have here the appearance or the first appearance of the theca folliculi. Here you can see the stromal cells, the blood vessels present in the medulla of the cortex. Another picture for the multilaminar primary follicle showing the 4 important events: the enlargement of the size of the primary oocyte. Notice the vesicular nucleus with prominent nucleolus with this star. The number 2, the appearance of the zona pellucida. Number 3, the appearance of the stratified cuboidal called granulosa. And number 4, the appearance of the theca folliculi surrounding this growing follicle. Another picture for the multilaminar primary follicle showing the 4 events we have said, in addition to the appearance of primordial follicle showing simple squamous epithelial cells surrounding the primary oocyte, which has this vesicular appearance for the nucleus. Here we have also stromal cells. Here we have, this is the oocyte, and this is the nucleus, nucleolus, zona pellucida, granulosa, theca folliculi. Here we have a picture to demonstrate the differences between the unilaminar primary follicle and the multilaminar primary follicle. You can see here that the 4 events, the size, the zona pellucida, the number of the layers, and the appearance of the theca folliculi. Here, this slide shows 3 types of follicles: the primordial with the simple squamous, the unilaminar primary with the simple cuboidal, and here this is an early secondary follicle. Why I have said early? Because of the appearance of these multiple fluid-filled cavities. Here another magnified early secondary follicle. It shows the large size of the oocyte. It may reach up to 120 micrometer in diameter. Also the zona pellucida is present as before, and here we have the first appearance of fluid cavities, which will differentiate this one from the multilaminar primary follicle. Here also you can notice another difference, which is a differentiation of the theca folliculi into theca interna full of these blood capillaries and theca externa, which is formed of connective tissue and some cells of which will differentiate or become as smooth muscle cells. So the appearance of the cavities and the differentiation of the theca folliculi into 2 layers, interna and externa, will make us diagnose this follicle as a secondary follicle. When the secondary follicle Here still we have multiple cavities, so this is also an early secondary follicle. But when the development of the secondary follicle is completed, you will notice that the multiple cavities will join each other together to form a crescent shape one fluid-filled cavity. So this is a late secondary follicle where the coalesce of the fluid cavities takes place to form a large crescent-shaped antrum. This part is called antrum. And the oocyte is always pushed to one side. Now it is not in the center as before, it is pushed to one side. Now with more maturation we have the mature Graffian follicle. Take care, Graffian is not written like this, it is double A, not double F. Mature Graffian follicle, the oocyte is 150 micrometer. It is surrounded by the zona pellucida, which is glycoprotein in nature. It is surrounded also by a first layer of cells, which are columnar cells called corona radiata. And we have also these cells that join the oocyte to the granulosa cells are called camulus oophorus or discus proligerus. And we have also the remaining granulosa cells, about 2 to 3 layers. Then we have a basement membrane in this area between the epithelium and connective tissue. Then we have the theca folliculi differentiated into interna and externa. The interna is characterized by having these blood capillaries. The externa is characterized by having connective tissue cells. It is less vascular and it contains some smooth muscle cells. Now this is another picture for the mature Graffian follicle. Now we will make a label for the various structures. This is the oocyte. It is primary, that changes to second just before ovulation. Number 2, it is the zona pellucida. Number 3, these are the cells which are called corona radiata. Number 4, it is the part on which it is resting on. It is called camulus oophorus. Number 5, it is the granulosa cells. Number 6, the membrane separating epithelium from connective tissue. It is the base membrane. Number 7, it is the theca folliculi. And number 8, it is the antrum or antral cavity. Here a higher magnification for a part of the mature Graffian follicle showing the antrum, the granulosa cells. Here is the base membrane and here is the theca interna, full of the blood capillaries lined by simple squamous full of RBCs. And here outside we have the theca externa, which is full of connective tissue cells, some of which will differentiate to give smooth muscle cells. Here another picture for the mature Graffian follicle. This is the oocyte. This is the vesicular nucleus with prominent nucleolus. This is the zona pellucida. These are the corona radiata. This is the camulus oophorus. This is the base membrane here. This is the theca interna, full of capillaries, and more superficial we have the theca externa. Also here we have a picture for the cortex showing the following structures. Number 1, the germinal epithelium, simple cubical epithelium. Then number 2, we have the connective tissue capsule tunica albuginea. Number 3, we have the primordial follicle surrounded by the simple squamous epithelium. Number 4, it is unilaminar primary follicle formed of one layer of follicular cells which are cuboidal. And number 5, here it is a degenerated follicle, so it is an atretic follicle. Number 6, we have the stromal cells, which looks as if they are spindle in shape. And this is all about this picture. Now we will move to another structure which can be seen also in the ovary, which is the corpus luteum. Corpus luteum here, it is of closed cavity. Here we have hemorrhage in the cavity, so it is corpus hemorrhagicum. And here we have theca granulosa, or it will be transformed into granulosa lutein cells. And here we have the theca interna will be transformed to theca lutein cells. Both of them, these two layers, will produce hormones, so it is a temporary endocrine gland. This is the corpus hemorrhagicum because of the presence of this blood. You can notice here some septa in the theca or in the granulosa lutein cells, in the granulosa lutein layer. Notice that the granulosa is much thicker than the theca lutein. It forms about 80% of the structure. This forms about 20% of the structure. This is central in position. This is peripheral in position. Both of them secrete hormones. They have steroid secreting cell picture under the EM. Here we have corpus luteum. We have the obliterated lumen, we have the granulosa lutein, and we have the theca lutein. We have some septa here in this area of the granulosa lutein, and it is located, of course, in the ovary. After degeneration of corpus luteum, either of pregnancy or menstruation, it is transformed into a fibrous tissue, which is white in color, so it is called corpus albicans. Albino means white. So it is corpus albicans, which is nothing but fibrosed, degenerated corpus luteum. Thank you very much. Let's move to another presentation for another part in the female genital system. Best wishes for all of you.